Okay, so for 4.3, we're looking at more discrete probability distributions. We have the geometric distribution, which was shown, and then we're also going to have the Poisson distribution, which I'd like to go over here to save you some time. So one of the big differences between Poisson and just binomial is, remember, for binomial, we have a fixed number of events, right? So we could have like 12 people were selected, or you're going to flip a coin 18 times. With a Poisson, we don't know how many times something's going on. We want to count how many times something is going to happen. So here are my requirements for the Poisson: that the experiment consists of counting how many times that event will occur in a given interval. The interval can be time, area, volume, but for the most part, we limit ourselves to time. So we're looking at how many times something happens in an amount of time. The probability remains the same, just like it was. The number of occurrences in one interval is independent of the other intervals. So if I'm flipping a coin in 10 minutes and I want to know how many times heads come up, that has nothing to do with how many times heads would come up the next 10 minutes. But if you notice, here's my probability, and the formula is kind of ugly, correct? We're looking at a mean in mu. X is my number of times the event occurs, and then we have E, which is Euler's number, which we abbreviate as 2.71828. Now, if you want to type this into your calculator, by all means, go ahead. I'm thinking it's probably easier just to use Excel, right? So here's the problem I'm going to be looking at to show you how to do it on Excel, make life easy. Find the indicated probabilities. This is number 8 on 4.3. Using the geometric distribution, the binomial, Poisson, or the binomial, determine if the events are unusual. Remember, unusual means that it's less than 5% chance. So after we do the probability, if I have 0.05 or less, that's 5%, then it's unusual. If convenient, use probability table or technology. Well, it's very convenient to use technology, so let's do that. Here's our problem. The mean number of births per minute in a country in a recent year was about 7. Find the probability that the number of births in any given moment or any given minute is exactly 5, at least 5, and more than 5. So it's a little tricky that we'll get to it. I'll explain when we get there. But is this a binomial distribution? Do we have a fixed number of trials? No, we don't. So we can't just use the straight up binomial from 4.2, right? We don't have a fixed number of trials. We're trying to find out how many times something will happen. But it is a Poisson if we look. We're looking to see how many times an event occurs in an interval. In this case, we're looking to see how many births occur in a minute. So there's our event, the birth, and our interval is a minute. The probability that the birth occurs is going to be the same. The number of births in 1 minute has no effect on how many births occur in the next minute. So they're all independent, and so this is a Poisson distribution. So using my Excel sheet then to make life easy for myself, I'm going to set it up this way. Just like we did binomial distribution, in this case, I will use it as Poisson distribution. I type in POI and there it pops up for me. Let's let the computer do it. When I double click, I get Poisson distribution. The first thing I want is X. How many times do you want something to occur? So for part A, I'm looking for exactly 5 times. So I put in the value of 5. And then I have my comma. Again, don't forget your comma. The syntax is very important with Excel. The next thing I want is the mean. What is the mean that they have for the problem? Well, in this case, it says the mean number of births in a recent year was 7. So my mean is 7. Again, comma. And do I want cumulative? Do I want to know all the way up through 7? Or do I want to know through 5? Or do I want to know exactly 5? And since I want to know exactly 5, I don't use cumulative. I just use the probability one. And I hit enter. Gives me my value right away. A lot faster than using this formula and typing on the calculator, if you'll agree. I got 0.1277, which rounds off to 4 places, it says. So I'm looking at 0.1277. Perfect. Now, what's the probability of getting at least 5? So now remember what at least 5 means. At least 5 means 5 or greater, right? So at least 5 is 5 or greater. Well, another way of saying 5 or greater, since I don't have an unlimited number of times, right? I don't know if it's 5, it could be a million. Maybe it's a really weird minute, and we have a lot of births. So instead of finding at least 5, right? And I'll put it out, this is exactly 5. What I'm going to do is find out what is the probability of getting 0 to 4 births. From 0 to 4. So if I do my probability, my poisson, I click on poisson. How many do I want? What is the number of births that I want? I want 4, comma, my mean is still 7. And in this case, since I want from 0 through 4, I'm going to use cumulative. So do you understand what just happened there? Since I want to know more, at least 5, it means I want 5 or more. But there's no way to type in the Poisson distribution to get more than the value. We can only do that value or less because we can do cumulative up to that value. So if I want 5 or more, the opposite of that would be 4 or less. And this is the probability of getting 4 or less. So if that's the probability of getting 4 or less, then 5 or more, at least 5 or more, would be the complement of that, which means I can do equals 1 minus this probability. And I got my value, 5 or more. 0.8270, I can plug in that value. Okay, again, the Poisson, unlike the binomial, we can't type in how to get more than a number. Whereas with Poisson, we have to find out the value that's less, and then we use its complement. If this is the probability of getting 0, 1, 2, 3, or 4, then this is the probability of getting anything more than 4. Lastly, what's the probability of getting more than 5? So notice what that is. That's very tricky wording, right? Semantics. This one says 5 or more. At least 5 means I can have 5 or I can have more. Now I want to get strictly more than 5. And I want to put it in the correct box. So how will I strictly get more than 5? Well, if I take the probability of getting 5 or more and take off the value of getting exactly 5. So I'd have 5 or more, take off the value of exactly 5, and that will tell me the probability of more than 5. So in other words, I'm going to do equals. Again, whenever I'm telling the computer to do something, I want to do this value, 5 or more, and I want to subtract off the value of exactly 5. And I'm getting a 6992 with a 9 hanger. So I'm going to do 6993. And I've got my answer. Okay, so be careful on the wording. Be careful how we set it up. The last part, which of these events are unusual? Are any of these events less than 0.05? This one is 12, 82, 69, so no. None of them are less than 5, and none of them are unusual, and I'm done. Okay, so, and I already did the next question. Next question, same idea, same thing. And I'd set it up the same way. So use Excel, get handy with the Excel. If you have questions on how to type it in, like some of your classmates did, please post it in the discussion. Hey, help me, help me. And be sure to type exactly what you typed in so we can see where you went off. Have a great week, and I'll see you in the discussions.